Is that now? My next question is, how do I navigate back to our site for our math or for our homework, like to read it and stuff? Or do I need to look that up on something else?
Yeah, you can just minimize this.
Oh, just minimize it?
Yeah.
Okay.
Or you can make it a smaller window, whatever works best for you.
Okay. Awesome. Just like that.
Yeah, click that one.
Okay.
Yeah.
Now go to, get another window here.
Well, don't you have, yeah, sure.
Okay. So no, hold on. I'm not done. Where'd it go? Oh my. Slow internet. Okay, now how do I find her again?
Go up to the corner to find out where she's at.
You're there. Okay.
Yeah.
Can you see her?
Yeah. Yeah, it's all still here.
Okay.
But I can't see.
Yeah, you can hear her though.
Yeah. Okay. Okay. So are we just supposed to just go through the preparation assignment then?
That's
Read
what
through.
it seemed like we were just like uh, the quiz is just the questions on the preparation assignment.
Okay. So do
So
we want to go through the assignment before we do the quiz, or just want to go with the quiz and hope we get them right, or?
why don't we go through them real quick just to make sure we know what we're talking about?
I think it's a good idea because sometimes in the preparation I was like, okay, I think these are the right answers, but not being able to check it, obviously,
Right.
I didn't know for sure. I didn't know for sure if I was, guessing right. So,
Me too.
okay.
First question. Are you ready?
It is not loaded. Review the wiki and group preparation to go over the preparation. Okay, hold on. I think I clicked on the wrong. Okay, so the individual preparation is technically our group preparation.
Yeah.
Okay, let me get there. Sorry, my internet is being really slow today. We live out in the middle of nowhere, seriously.
Oh, that's totally fine.
Yeah.
I'm in the middle of and mine is really slow too. So
Oh, where do you live?
Provo.
Oh, do you?
Mm-hmm.
Is your husband, I guess, in school?
USWI.
Oh, that's exciting. Good times. Okay, review questions. Do you wanna read? Do you want me to read?
I can read.
Okay,
So first
cool.
is what is the name of the important statistical result that guarantees that the sampling distribution of the sample mean will be normal if the sample size is large. So I put central limit theorem for that one.
That's what I put.
Okay.
Okay.
And the second one was just asking the same thing, but the sample mean will be close to the population. So I
Yeah.
put
Yep, that's what I got.
Number 3. Which of the following variables are categorical?
Okay.
Number 1, the animal or the number of animals in the local zoo. 2, a selected brand of toothpaste at a convenience store, and 3, age and years of a randomly selected vehicle in a parking lot.
Okay. I put the choice 2.
I put 3.
Did you? Okay. I thought categorical was something that was. What are the other options? Categorical or
numerical?
numerical?
So the first one was numerical because it's counting the amount of of animals.
Yeah.
Now that I'm looking, I think it might be 2 and 3.
Oh, okay. Which of the following variables? Yeah, good point. There may have been 2. Because
the randomly selected toothpaste is like it's a type of toothpaste. So that would be category. And then
Yeah.
age and years of a randomly selected vehicle. You're not like counting the number.
Right, you're just stating the
Right.
age. Okay, yeah, I think you're right. So 2 and 3.
Yeah.
Okay, awesome.
So number 4, the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores were 112. Which of these two numbers is the parameter and which is the statistic?
Okay. I put that the statistic was, oh, hold on. The mean test score in the United States was 100. I put the 100 was the statistic. No, sorry, I put the 112 was the statistic.
Okay, yeah. Yeah.
Okay, and the 100 is the parameter.
Right.
Because the statistic is related to, it's related to the sample, right?
Yeah, yeah. So
Okay.
I was actually wondering if they wanted just the mean or if they wanted like the whole thing. So the statistic would not just be the mean of 112, but it would be the 20 random students whose mean was 112.
I don't know. It just says that which of these two numbers is a parameter. I think they're just trying to make us identify which one is related to the population and which one is like related to the sample.
Yeah, I think you're right.
Does that make sense?
Yeah, it does.
Okay. So what did we say? 112. Let's see. 112 was the mean of the sample, so that was the statistic,
Right.
and the 100 was the parameter. Okay. Awesome.
Number 5, Rothman City has 4 distinct neighborhoods. The property types are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' response to a proposed increase in property taxes?
Okay.
So
Go ahead.
I chose stratified for that one.
That's what I chose too. But I had to look it up because I couldn't remember. And the thing that it kind of made me decide on that is it said that the stratum tend to differ from each other. And since the neighborhoods were very different, that's why I justified it.
Yeah, that's pretty much why I chose it because it was they picked
samples.
I totally sorry, my baby's making noises and so I'm trying to.
Oh, that's okay.
Yeah, so they picked a sample of from each group.
Yeah, that's why I picked it too. Sample from each group, and the groups were different. So, okay, cool. Sounds good to me.
Number 6, when designed experiments are conducted in public school systems, researchers typically choose a particular district and randomly select the 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented?
Okay. I put cluster.
Me too.
Okay. Sounds good.
Number 7. Are you good to go on?
Yeah, I'm good.
At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented?
Okay, this should be really easy, and I'm going to feel really stupid, but is it just convenience, or is that the simple random?
That's a good question. I put simple random sampling, but I didn't even that. It could be.
Well, I was confused because it said, so on the simple random, it said you have a list of all items in the population, which I guess they do because they have the hat, and they have everybody's name, but it says it uses software to obtain the samples.
Right.
It just says use a software, and convenience was they said it's the worst kind because there's no I can't even remember what I don't know. But I just wondered if it was convenience because they said it was the worst kind to use and you shouldn't use it very often. But it may just be simple. But I know that it said specifically that they use software to obtain the sample.
You're right about that. I don't know.
I don't know either.
I would go with simple just because they're not just um, asking random people and they're not like having someone stand in a corner and
right.
ask
Yeah.
They're doing
they're getting everybody's whose name is and they're just drawing it out. So it might be simple. I just didn't know if it was convenient. So I can go with simple. That would be fine with me.
Yeah, that's a good point. I didn't think of that, but I think it might be simple.
Okay. Okay, let's go on. I'll put a little star by it. Not that it matters, but.
Number 8, a special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers the registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling was implemented?
Okay.
Number 8. I chose stratify.
I did too.
Okay. Cool. The next one is on that program.
Yeah.
But I don't have it up because did you do it?
I did. Yeah.
We don't need to pull it up.
Yeah.
What did you get for the? So we need to find the mean, the standard
deviation. Yeah.
Yeah, deviation, and the 5-number summary.
Okay. I got, you said you didn't do it or you did?
I did, yeah.
Okay, so for the mean, I got 4.771.
Yep, that's what I got.
Okay, the median, I got 5.1. Is that what you got? Yeah.
Let's see. I got 4 points. Hold on a second. I'm gonna pull.
Okay. And I remember being confused as if I was doing this right or not.
Let's see. Where's that? Okay. So the median, are you talking about for the 5-number summary?
Yeah.
I probably did the 5-number summary wrong.
Well, I may have to. Okay, so did you get for the standard deviation 1.911?
Yeah, I did.
Okay. And then did you use like I can't remember. Let me just try it. I don't remember what I did. Like there was a way to get the 5-number summary on the.
I just added everything together.
Okay, what was the name of it? I can't remember. The data set. I don't remember the name of it. I just went backwards.
Purchases.
Oh, sorry. What was it?
Crossroads purchases.
Crossroads purchases. Okay. Crossroads purchases. There we are. Takes a minute to open up. And I don't remember, like we were supposed to be able to get the 5-number summary. Was it doing a box plot or was it doing something else?
So I'm pretty sure I did it wrong, but the way I did it was I went to the top where it says analyze.
Yeah.
And then I went down to, where is it? I'm just going to do it again so I can.
Yeah, and that's what I'm going to try to do.
Analyze.
Okay, mine is being super.
And then I went over to descriptives and put amount in the place. I've moved it.
Yeah, over into the variable.
Uh-huh. It gave me the minimum, maximum, mean, and standard deviation.
Yeah.
And then I'm
Did
seeing
you
what I
get,
did.
on the minimum, did you get 0.84?
Yeah.
And the maximum 10.45?
Uh-huh.
Okay, so we're just missing, we're just not the same on the median?
Yeah. So what I accidentally used the mean as the median.
Oh, okay.
I'm seeing where I made my mistake. So
Okay.
if I
Okay.
do the math again, I'd get the right median, and I do
Okay.
have. We'll see if I can figure that out real quick.
Okay, and mine is not responding for some reason. I have no idea why. It says SPSS statistics client scripting failed to start. I
Oh,
have no idea why. Um,
my SPSS is going really slow today. I don't know why.
okay, well, I don't even know how to get back to my, oh my goodness.
Did you the free version? With
No, I didn't. I had to pay for it.
you paid for it? Okay.
Yeah, so it better work. Dang it. You know what?
Huh.
I did see though somebody or something that it was going to expire or something,
Really?
but I paid for mine. So, hmm.
I
Okay,
didn't.
I don't.
I'm using the where I'm connecting to the BYU Idaho computers.
Yeah. Oh, okay.
So that I still have it. So I don't know.
Okay.
I didn't get that message.
Okay. Well, anyway. All right. So did you rework it and the median is 5.15?
5.105.
Yeah. Oh, I got 5.15 unless I wrote it down wrong. I may have written it down wrong.
And then let's see. And then you add the 1.9 to each side.
For the standard deviation?
Yes, that is the standard deviation. So then we add 1.9119 to 5.15, and that gives you the top two numbers and then the bottom two numbers for the 5-number summary.
No, because the quarter, the first quarter and the third quarter, is that what you mean? For the five
Um,
number summary?
I think so.
Oh, wait, hold on. Mean? Oh my goodness. Um, five number summary includes what? The mean, the minimum, the maximum, the median, and the standard deviation. So we have all those, right?
Yes, I
Okay.
was trying. I okay. I see what we're doing. We're good.
Okay.
Yes. Okay. Let me just write that down so I know I don't make that mistake again.
All right.
Okay, we're good.
Okay, cool.
And then number 10 was just make the histogram. Do you remember how to do that?
Yeah, I remember just going to graphs or I can't
Yeah.
remember, like dialogues and histogram or something like that. Did you get the first quartile though?
Did I what?
On 9, were we supposed to do the quartiles or did I make that up in my head?
I
Oh,
didn't do it.
okay, I did make that up in my head. I don't know why I thought I needed that. Okay, go ahead. Yeah, I did histogram.
That's what I was trying to do for the 5-number summary.
Okay, I think I tried to add those in as well. Okay, oh well. Number 10.
That's the histogram.
Oh, okay,
And
yep,
that's just
I
on.
did that. Okay.
So number 7 is what is the value of the number that goes in the position marked with an A on. Oh, to the
Yeah.
table. We have to put in the table.
Yeah. Okay.
So for that one, do you remember how to do that?
Yeah, is it just x minus the mean is a, right? So 37.91 minus the mean, which was, I don't remember now what it was.
It's 38.075.
Yeah. So for
Yeah.
A, I got negative 0.165.
Yeah, that's what I got.
Okay, cool.
And then for 12, it was that you just have to square. You do the same thing, but
Yeah.
and then square it. So I got
Yeah.
0.681.
Yeah, I got 0.680, so maybe I didn't round at the same time as you or something.
That could be. It looked like I put 0.680 and I crossed out the 0 and put 1.
Oh, okay. So maybe,
And the-
alrighty. Probably pretty close. Okay.
Number
13?
13. What quantity is equal to the sum of the numbers in the squared deviations column? So I put variance.
Yeah, me too.
Number 14. What is the standard deviation? Oops. What is the standard deviation of these temperatures?
I just got 1.238.
I got 0.715.
Okay, so how did you do that?
So
Did you get it for the added up?
Yeah, so I added all the squared, like the column.
Yeah. What did you get there when you added them up?
1.534.
That's what I got. Well, I got 1.533. So, and then you just took the square root of that?
Then don't you have to divide it by I divided and then took the square root of whatever. What did I divide by?
Did you divide by the number?
By 4 minus 1. I don't know why I did that.
Huh. Let's see. What would 4 be?
Let's
For
see.
I remember doing 4 minus, or like a minus 1 on something, but I don't remember what we did it for. I thought the standard deviation was just the square root of the variance.
You could be right. I did the square root after I divided.
Right. Okay.
Not sure why I divided though.
I'm not sure either, but I remember vaguely doing something minus 1, but I don't know what it was for.
The reason I did 4 is because there were 4 numbers that I
Yeah,
added together.
and I think that would be for the z-score, right? Because that was the only time we divided by the number.
Oh, that's probably what it was. Yeah, I'm not sure what okay. Let's see. 1.534. Oops. That's 5. So then it's 1.239.
Yeah, I got 1.238, so somewhere I must be slightly off, or we're just not rounding at the same spot, or...
It is 1.238, but there's a 5 after it, so I rounded up to 9.
Oh, okay. I wonder why I didn't do that. Okay. Probably because I was rushing, as usual. Okay.
Okay, perfect. Yeah, okay. We're good. So number 15. True or false, under certain conditions, the standard deviation can be negative.
I put that as false, but I couldn't find why I put that.
So the reason I put false for that was because you have to find the standard deviation, you have to do a square root, and you can't have a negative in the square root.
Okay. And I was thinking it was something about a standard deviation is how far from a mean, and I thought it was measured in absolute values, which can't be negative.
Exactly. Yeah, that's true too.
Okay, so we can just go with false.
Number 6. In the same study, the researchers placed temperature sensors on 3 seals near their spinal cord and brain in the extradural vein. They placed these temperature sensors in 6 other seals in their aorta, the largest artery in the body. Finally, they placed the temperature sensors in 4 other seals in their hepatic sinus. The result from the study are summarized below in the table. Which location resulted in the most constant temperature measurements from one seal to another? I put the extradural because it has the deviation from the mean.
The smallest?
Mm-hmm.
Yeah, that's what I put too.
Okay. Number 17, in your own words and without using any mathematical symbols or statistical jargon, explain what the standard deviation is. Do not tell how to calculate the standard deviation, but explain what it represents.
Okay. Thought that was funny that we couldn't use any mathematical terms because that made it kind of hard to do.
Exactly.
I just put, it tells how close together or how far apart the data is, hold on, how close or how far from the mean that a sample is. But I used mathematical jargon using the word mean, so I don't know how else to say it. What did you put?
I pretty much the same thing. How far away the sample is from the average.
Okay, that's better.
So pretty much the same thing.
Yeah. Okay.
Number 18, give the 5-number summary of this data. So the box plot that's on
Yeah.
there. Let's see.
Okay.
I put 2, 4, 6, 8, 12.
2, 4, 6. Let me see what I put. 2, 4, 6, 8, 4. Oh, I put 14. The only reason why is because I remember them saying if there was a mark, an X or an O above, that's actually the maximum. But I could be totally wrong because that 12, like I don't remember exactly, but I remember so that little dot that's at 14.
Yeah.
But I don't remember, like that's worth looking at in our notes.
Yes. Let me look it up real quick.
Okay, sounds good. In the box plot area.
That's an outlier, right?
Well, yeah, I guess.
Mm.
And it says what the median isn't affected by outliers, but would that be a maximum?
Let's see. Okay. Calculator settings give the box and whisker plot with the outliers. Okay. The whiskers only go as far as the highest and lowest values that are not outliers. Okay. So does that
Those whiskers
mean,
are the little things on the ends, right?
yeah. So let's see. Can we? Huh. Doesn't say anything about.
About the little circles.
Well, it does talk about the circles. All it says is they're outliers. It doesn't say.
If they're maximums or.
Yeah.
Okay. Okay, so maybe we should just go with 12.
But I think you might be right. It just doesn't. It just doesn't talk about it. It doesn't.
Yeah, I remember seeing it in like an odd place. It wasn't with the. So are they trying to trick us or?
I don't know. It looks like it's be a trick question.
I know, it really does. So,
Let me try one more thing.
okay.
Oh. Okay. So it looks like they're just outliers. You wouldn't count it
Okay.
as the max.
So don't count it as the maximum. Okay. So 12.
That's what it looks like. I hope it's right.
Oh yeah, okay. And I guess if it's not, we'll know for the test, right?
That's true.
Okay. Sounds good.
That was 18, 19. What percentage of the data lies between 4 and 8 hours? For that,
Okay.
I put 68%.
Okay. I put percent, but I don't think that. My question is 4 the first quartile? And is 8 the 25? Would it be 50?
Sorry, you cut out. I didn't quite hear what you said.
Okay. I was just thinking, was 4, so the bottom of the box, does that represent the first quartile?
That's what I thought.
And 8 would represent the third quartile. I wrote 25. I have no idea why.
Huh. So the reason I put 68 was because I was thinking more of in like the standard deviations,
Yeah.
which could totally be just what was going through
But
my head.
that middle
So
number, the 6, is the median. It's not the mean.
Right.
I just thought the bottom of the box was the first quartile and the top of the box was the third quartile. And so between those two, it would be 50%. But I don't know why I wrote 25. That doesn't make any sense.
That could be right. I actually don't know.
Okay.
I guess it would depend on if you're going off of quartiles or deviations.
Right, but this doesn't tell us the deviation, does it? This box plot thingy?
It must not. I think you're right. I think it must be 50%.
Okay, that's just my guess because I think 6 is the median, and then it shows the minimum, the maximum, the quartiles, 4 and 6, and the median. So that's my guess. So does that make sense?
Yeah, it does.
Okay, so between 25 and 75. Okay, well, we'll guess at that. So we need our 2 other brains to make sure, figure out who's thinking right.
No. Let's see. 20. Estimate the
And
mean.
I don't think I did this one
right. Okay. Did you say?
Oh, I just said I don't think I did the next couple right, but we'll find out.
Okay, that's fine. For number 20, it says estimate the mean of the measured nitrate concentration in Rexburg's drinking water.
Okay.
So for that, I
got
0.055.
Okay, I got 0.233. Okay, let's see. An observation from there are several contaminants that come above is between okay, the reason I
found I'm getting the mean and the median mixed up. That's the median.
Oh, that's okay. Did I even get the median?
I don't think they ever asked for it. I think I just mixed it up and found it anyways.
Okay. I was like, oh, I don't remember that.
Yeah, that was wrong there. So how did
That's
you
all right.
find it?
So I just drew one out. Did you draw it?
Draw it?
I just drew this one out because it says that we will assume 1.59 parts per million is the value of U, which is, or mu, which is 0 on your little diagram, right? Minus 2 standard deviations. So 1.55 was 2 standard deviations away. And 2.52 was 2 positive standard deviations.
Mm-hmm.
So I don't remember how I figured out what was the middle of that.
2.52.
Did I average them?
And then I took oh, there you go.
Mm-hmm. Yeah.
And then I took okay, so here's what I did. I subtracted them and divided it. Wait, hold on. Let me make sure I'm doing this right.
Okay.
0.5.
I know, I can't remember what I did.
Okay. Hmm.
Oh, that's 2. Oh,
So I am getting, yeah, 2.055. So what I did is I subtracted 2.52 from 1.59, and I got,
okay.
but that doesn't make sense to me why I'm doing that.
Okay, while you're thinking on that, think on this for a second.
Okay.
Okay, so if we are on our little applet thing, which I didn't actually use,
Mm-hmm.
but it says that 1.59 parts per million is the value of mu minus 2 standard deviations. So if we were on our little, our horizontal axis, -2, if we had a z-score of -2, that would be equal to 1.59 parts per million. So could we solve it for x? I don't know. I don't know what I did. I can't remember what I did.
What did you get? What was your answer?
I got, well, it doesn't even make sense. It said I got 0.233, but that doesn't make sense because, oh, hold on. Am I looking at the right answer? Yeah, 21. Estimate the, no, 20. Hold on. Oh, I got 2.055.
Yeah, that's what I got.
Okay, how did you get it?
Okay.
I don't
So what
remember how I got it.
So what I did is I took 2.52 minus 1.59 because those are
Okay.
the two numbers,
Yeah.
and I 0.93,
Sorry. Say that again. You cut out.
and so I got 0.93,
Okay.
and then I divided that by 2
Okay.
and got
Just because
0.46
that was it.
and got
Uh-huh.
got 0.465,
Okay.
and then I added 1.59 and got 2.055.
Okay. Why did you add the 1.59?
Because the 0.465 is just the
Uh-huh.
amount that I'm going up or down. So it's not the actual number. It's
Oh,
just,
the standard deviation?
yeah, so it's just the difference between the bottom and the middle.
Oh, okay. Okay. So it came up the same thing, 2.055.
Yeah.
Okay, that's really bad. I can't remember how I did it, but nonetheless, that's what I got to.
Okay.
Okay.
And then, let's see, 21. So then the second one was estimate the standard deviation of the measured nitrate concentration in Rexford's drinking water. And so for that, I got
Okay.
0.233.
That's what I got.
Okay. And that I got that from, so that 0.465, I divided that by 2 again, and then added that
Okay.
to 0.055.
For the two values? Or are you on number 22 now or still on 21?
21, I was just saying how I got that.
Oh, yeah, yeah. Okay, that's what I did.
Okay. And for 22, let's see where, okay. Between what two measured nitrate concentrations do approximately 68% of the data values lie?
Okay. I got 2.288 Or, well, that was the top one. So 1.822?
Yep.
Okay. And then
That's what I got.
2.288. Okay.
And then for
All right.
23, what is the mean and standard deviation of the standard normal distribution?
Okay. I don't know if this is right, but I just got 0 and 1.
Okay. I got for the mean 2.055, and then for standard deviation 0.2325.
So the same things as we got in the other, in number 20 and number
Right,
whatever.
except for the standard deviation. For that one, I did that formula with the mean on top and then
Minus
underneath,
the population mu.
something like that. I was not very neat in my work, so I can't see what I did.
I know, me neither. I have scratches all over and I can't even figure out what I did.
I even rewrote everything to make sure I'd be able to read it later, and I didn't.
Oh, that's really good. I didn't do that.
But I think I did like that mean over the square root of something.
Okay, so, on 23 then.
Uh-huh.
So the mean, what is the mean? Did you just take the same mean that was from 20? Because it's always the mean is the same as the population
Yeah.
mean.
Actually, a
Okay.
similar in our from last week in
Uh-huh.
work.
Uh-huh.
See if I can find it. That's how I knew where to do it or what to do.
Okay. Okay.
Standard deviation. Where is it? Okay. That's right. So I took the mean and divided it by the square root of n. I don't remember what n is.
I know, because we don't have an n.
Yeah.
N is the number, like when we have the number of samples, right?
Yes.
Unless reports.
I don't know what I did. I don't know how to do that.
I don't know either. The only. Oh, go ahead.
Because now I'm talking through it, it doesn't make sense. I don't know why I would do it that way. But in my head,
Well, my only guess is this. If you think about on the normal applet thingy, it always says that the mean, like let's say we have a mean of 3 or 3 point whatever. On the horizontal axis, the x line, the mean is always at 0. And the standard deviation, no matter what it is always at 1. And so that was why I 0 and 1. I don't know if this is a trick question, because it's talking about the standard normal distribution versus what they found in their research. Does that make sense?
So I see actually where I went wrong. I was still applying it to the question before.
Yeah, well, and that's what I thought at first too, but then I thought, as I was reading through it, I'm like, there's not enough information for us to figure that.
Yeah, well, and in the question it says to answer them 20 through 22, and that's 23.
Oh, I didn't even look at that. Okay.
I just that right now. So you're right. So the
mean
is, the standard deviation is 1.
Okay. Okay.
Then yeah, then it makes sense.
Okay. All right. Well, I'm glad I wasn't crazy. So.
So 24, the admissions committees for most Masters of Business Administration programs require the graduate management admission test as part of the application for new students. It has been shown that the scores on the graduate management admissions test are normally distributed with the mean of 542.3 and a standard deviation of 120.54. The minimum GMAT scores required for admission to the MAC program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. Use this information to answer questions 24 through 32. Okay. So 24, what is the probability that a randomly selected student will score above 542.3 on GMAT?
Okay, hold on. I don't see my answers for these, which means I put them somewhere else. Let me find them real fast. Oh, here they are. Okay, I'm ready.
So for this one, I got 0 somehow, and I know that that's not the right answer. I couldn't figure it out.
You know what? Hold on. What is the probability? I got 0 too.
Oh, you did? Okay.
No, wait. 24. Hold on. Yeah, I got 0. No, which means 50%. Because if your z-score is at 0.
Oh, that's right. You have to enter it into the applet thing.
Applet, yes. And so 50% are going to score above it, and 56% are going to score below it. So if you're at 0. So you were right. You just needed to plug it in to get the probability, the area.
Awesome. Good. I was like, I've done this a million times. I just can't figure out what I'm doing wrong. Okay.
I know. Well, it's so confusing. It's like they're setting us up to trick us. I don't know.
Okay. So
Okay.
20. What is the probability that a randomly selected student will score below 600 on the GMAT? For that, I got point. You know what? I did the same thing. I didn't enter it into the applet, but I got 0.6840. So if I enter that in.
Yeah, that's what I got too. 0.68 or 868. Hold on. Did you do 600 minus 254.3 divided by 120.54?
0.684. That's what I got, right?
That's not what I got, but I could do it wrong. I didn't write very neat. I really should have. Okay, so I did you do the 600 minus 254.3 divided by 120.54 for the z-score?
I am assuming so. I didn't write down my work. I just did it in my calculator.
Oh,
But
okay. That's what I did, and I got 0.998 for the probability.
Okay, let me redo it. Let's see.
Okay.
So it is, let's see, 600. 600 minus the mean, which is 2.3.
Okay, say again. Not minus the mean, right? It's minus the mu, which is. Did you say 254.3?
542. Say that again. Sorry.
Oh, I might have transposed these numbers, which means I did them all wrong. Let's see. I subtracted 600 minus 254.3, but it should have been 542.3, right?
That's what I put down.
Yeah, okay. I did all those numbers wrong, so my answers aren't going to be right.
Oh, okay.
Okay, let me do them again. 600 minus 542.3. 57.7 divided by
120.54.
0.54 would be equal to, so 0.479?
0.479, yes.
Okay, and then plug that z-score into the applet, and then we should get the probability.
Yes.
Is that right? Okay, let me get to the applet thingy.
And we're shading in.
Let's see, we'll score below, right? Or doing 25?
Oh no, yeah. So I did. Okay, so it's. Oh yeah. Okay. So it's So it is 0.6840, but you have to move the decimal place, so 68%.
Yep, 68%. That's what I got now that I entered the numbers in correct.
Okay.
Or 0.6808. Okay.
And are you good?
Yep, I'm good.
Okay. So for 26, what is the probability that a randomly selected student will score 600 or above on the test? So then you don't have to do any more math. You can just shade in different parts of it. So it's 30.
Yeah, and since I did it all wrong, I'm gonna have to count on you because for all the means I put in the wrong numbers. I put 254.3 instead of 5 whatever 24.
That's all right.
So
that's totally fine. It's 0.316. So I'm assuming she wants us to round to 32, so it'd be 32%.
Okay, just a second. Yep, 32.
Okay.
That's what I put.
Awesome. Okay.
Okay. 27.
27. Fine. Okay, so I actually did not know what to do for 27, 28, 29, or 30.
Okay.
I feel like there are things I should know how to do, and as soon as
I know, these are confusing. Isn't it that percentile is the same as area? So you go up to the area and you point in or type in 0.1 for 10%. And then you shade everything below the
smaller part, the left side.
Hold on, I don't know. 0.1. Yeah, so would it be, okay, what was the question asking now?
It was asking
first quartile.
Find the score that corresponds to the 10th percentile.
Oh. Okay, so then that would give us the z-score. Once we shaded in, we got a z-score of negative 1.282.
That's right, and then you have
Is
to
that right?
solve.
And then solve for x.
Okay, that's right. I knew I was gonna. That's okay. Perfect. Thanks.
Yeah, no problem. And like I said, I transposed these numbers on all these problems, so I'll have to redo them. So it would just be x minus 542.3 divided by 120.54.
Hold on, let me write it down real quick. Okay, so it's going to be 1.282.
Negative 1.282, right?
Yeah, thank you.
Times
is 542.3 and O is 120.5. Wait, no, 0.54. Yeah.
Okay. I don't know if you're ready.
Almost, hold on.
Okay.
Okay. I got 387.76.
That's what I got.
Okay, awesome.
Okay.
Okay. And then we do the same thing, but for the 90th percentile, right?
Yep. Yeah, so then we'd have to go with a z-score of 1.282.
Yeah. Not negative.
Which is just opposite. Yeah, not negative this time. And then x minus 5. Same thing, same process, but. So, 1, 2. Six 96.83.
696.
Yep, 0.832 or whatever.
Yeah.
Okay. 3 decimal places or 2? I never can remember.
I think she usually asks for 3.
Okay, so 832.
Down the whole number though, so when we go to the quiz thing, we'll know.
Oh. Okay,
That was
yeah, that's true.
the case. Okay.
Okay.
29. Where's 29? Find the first quartile of the distribution of the test scores.
Okay. I think I did the 0.25 again in the area.
You did what?
And then I think I did just put 0.25 in the area again and solved for the z-score, which was negative 6.74. Sorry, negative 0.674. Does that sound right?
So you put in 0.25 in the applet thing?
Yeah, in the
Right.
area. Yeah.
And got negative 0.64, 674.
Yep. And then I solved for x again.
Okay. Yes, that is right. I have to do it real quick, but
Okay.
that's how we do it.
X, and so the same thing, minus 550, 542. I don't know why I can't do that number. I messed that up. 120.54. Okay, I got 623.54.
I got 461.
Okay. Oh, I wonder if I didn't do negative. Hold on. Negative 0.674 times 120.54. Plus 542.3. What'd you say you got? 461?
Yep.
Okay, so I did do the negative. 0.56 or whatever.
And then for
Okay.
the positive. Oh, that's what you did the first time, was the positive one.
Yeah. So now do the third quartile, which is 0.75.
0.674. Well, it should be the. Is it the same thing? But wait.
Well, yeah, it should be like positive 0.674 and solve
Yeah,
it
so-
the same way.
Right.
X 42.3.
Times.
And then plus. So that one should be 623.43.
Yeah. Okay. Perfect.
Okay. Okay. 31.
Consider. There goes that. Okay. Consider a simple random sample of n equals 15 students taking the test. What are the mean
Okay.
of the distribution of sample mean scores for all such samples? Okay, so I got, for the mean, I got 542.3. And for this distribution, I got 31.123.
Okay, 31?
Uh-huh.
Okay, I did that wrong. I don't know what I did. Okay, what are the mean and standard deviation of the distribution of sample means for all such samples? The mean was the 542.3, right?
Huh.
Okay, and then the standard deviation was, what'd you say, 31.123?
Yeah. Yeah.
31.123, okay. Okay, yeah.
And then for 32, or are you good on that one? 31.
Yep,
For 32
yep.
is what the probability that the sample mean GMAT score for a SRS of N 15 will be greater than 600.
Okay.
Oh, so then you
600 minus 3 divided by 120.54 divided by the square root of 15.
uh-huh.
Okay, because I put the number in again wrong. All those questions, I put that number in wrong.
Oh, no.
Rar. 600 minus. I hope I don't do that on the test because that would mean I would get all of them wrong.
Oh no, yeah.
57.7 divided by, what's the square root of 15? Let's see. .873. So 120.54 divided by 3.87 equal to 31.123. So 57.7 divided by. Okay, 1.0. Did I do that right? 1.53 would be, that's the z-score, right? And did you use the app thing? Eight, 5, 4. Okay. Did you get 3.03? Uh-oh. Are you there? I think I lost you. Madison? Oh. Okay, I don't know how to answer this thing.